Hello, good morning. Anybody hear me?
Good morning, sir.
Thank you, Mr. Mark.
Good morning, sir.
Okay, I can't see everybody all together, but good morning to you, everybody. I'm very happy to be with you again, and hope you all are doing great. All of your families and friends are safe and sound. May God bless you all. Please allow me to introduce myself one more time. Uh, my sound is clear to you all, Mark, Mr. Mark.
Yes, sir. Very clear.
Okay, thank you so much. So, I am Arup Kumar Bishesh. I am a PhD fellow having a research in unconventional coal technology. So, I think you all have a little idea about coal and coal technology, but I will talk about unconventional coal technology also. And uh, hope you can remember me from my last session of Sustainable Development Goals. uh, you can see that I have used the SDG logo here again, which implies that all kinds of development activities ultimately coincides and integrated into the SDGs, either in micro or macro level. And our today's topic is directly related to goal 7, which is affordable and clean energy, and goal 13, which is climate action. And following our schedule, I will talk about clean coal technology today. Mm, I hope my previous fellow instructors have already triggered the concern of global warming and climate change issues among you people. So, to such an extent that today's topic might look a little controversial. I'm not sure though how many of you are passionate enough to hear anything related to coal. Many of you are, in fact, dead against coal, I guess. I cannot blame you actually. The prevailing perception is actually triggering the biasness. Uh, we know coal as an extremely unpleasant material to burn. It exerts smoke, it pollutes the environment. It's all bad. But today, I would like to interact your knowledge base of coal development from a different perspective. So I hope after my session, you may have a different opinion. Uh, So uh, we'll talk about coal as a whole, uh, its history, importance for building the civilization, and its impact on the environment a little bit. And I will talk about the conventional uh, coal extraction strategies and the problems related to that. Uh, I would like to start with some essential coal information like coal rank, coal quality, what is called coal grade also, different kind of mining methods. So all these things are very important. Please have in mind that all this information is very necessary to understand the underlying issues, and this is also necessary to interact with the clean coal technology perspective. So, please be with me. Uh, before start going into the whole clean coal technology perspective, may I ask you that what is your perception regarding coal or clean coal technology? Let's start the session being interactive from the very morning. So, so can I ask you, or can I tell you to join me into the discussion? What is your perception regarding coal? The, if you just share your ideas in the beginning, we will see after the at the end of the session we'll wrap up. Before wrapping up the session, we will talk again that whatever you have collected from this session. But before starting, let's hear from your end also. So uh, so would you care to share with us that what do you think about coal, clean coal technology? Is there anything anything named clean coal actually. So what do you think? If anybody comes forward, is there
Hi
anyone?
everyone,
Yeah, who is this?
this is Christine from Guyana.
Miss Christine, please.
Hi everyone, I hope you had a good weekend. So happy to join again. My thoughts on coal. So where we are right now, I think we have a lot of it because of coal and because of the use of coal. We're here today. So we wouldn't be able to afford this kind of lifestyle if it wasn't for coal and other fossil fuels. However, moving on and knowing that climate change is real, and the impacts that fossil fuels has on the environment, I think that we're at the point right now where we have to move away from coal. I know some people talk about clean coal, but I don't think that's a good statement because there's no such statement as clean coal because it has a very dangerous impact on the environment. However, there are other sources of energy that we can be using. Thank you.
Thank you, Christine. Anybody else? I will check how many people here today. Uh, hmm, there is Mr. Arlene, there is Miss Emmeline, Miss Harmawan, Mr. Harmawan, Mr. John Paul, Miss Kia, Mr. Mark Kachin, Mr. Marcelo, Miss
Yes, sir.
Melissa, Mr. Michael. Anybody else care to join the discussion?
Yes,
Care to
sir.
join? Who is this? Miss Kia.
Yes, sir. What was the question again, sir? I'm
So
sorry.
this is not the question. Just
I
we will talk about something about controversial clean coal technology, as Ms. Christine just said that there is nothing like clean coal. I will try to iterate your knowledge base on that perspective. But before starting my thing, I just wanted to discuss with you people what is your perception about coal, clean coal technologies, whatever. What do you think actually?
yeah. Coal is, coal is readily available. It's commercially available, and it's the least expensive source of energy. And for us here in the Philippines, we use coal. No, majority of our processing plants. Yeah. Um, our processing plants, especially here in my place in Zamboanga City, we are the what's this? We have a lot of sardines processing company, and we use coal for the production of sardines. No, and I think one disadvantage of the coal is using coal as energy is its disposal. It has been a long time problem here in my place about the disposal of the coal ash, and until now it has not been addressed. So I think that's the disadvantage of using coal, and it's also it's hard, and it takes time to replenish the coal resources that we use or we extract.
Thank you, Ms. Kia. You are very specific on thing. You have mentioned that disposal might be the main issue. That coal,
Yes.
that is coal handling, coal transportation, the coal just after the mining, after
Yes.
extracting the coal from the subsurface, how we use on the surface, that poses the environmental degradation, and the major concern is that actually. So you are very clear. And according to Christine, is a total havoc. Is there is nothing good, and there is no way there to be a clean coal actually. Okay, so just from those perspective, uh, I will pick those points. And anybody else want to join now, or no worries, we can keep on going. We can talk later also. Is there anybody? Nope. Okay, so let me get back to my slides. So uh, uh, at the end of the session, uh, uh, at the end, there is something regarding Kia's concern. Ms. Kia was concerned about this thing, and that has been the major and the foremost concern for this indigenous resources, which is plentiful, which is vast around the world, and which is readily available always, what she said. And this has been feeding the growth of the civilization for centuries, actually. So we just cannot deny its importance still. We are trying to find out the alternatives, but those are on the way. Still, we have to look for we have to find out the good ways to exploit this huge resource onto the earth. Let's look at what I mean. So, uh, these are the IEA, International Energy Association, and BP, British Petroleum data. So they say that even in 2019, we still don't have the 2020 compiled data. Even in 2019, the data is something like this. Total energy consumed was 42,000, 42,200 million ton oil equivalent. So around 40% have been used for the electricity generation, which is the major sector, and you can see the coal dominance in electricity generation world, and in the total energy mix also. I told about the energy mix in the last SDG session, but you can look at here that the world is consuming this much energy, not the amount is mentioned here. It's 42,200, around 42,200 million ton oil equivalent, MTOE. So uh, uh, in that mix, energy mix, you see that fossil fuels, I mean oil, coal, and gas combinedly, they are comprising 84.3%, and low carbon sources are these nuclear, hydropower, wind, solar, biofuels. So hydropower and nuclear, they have considerable good good shares, but solar or other renewables, those are very scanty, very negligible actually. But if you look at the electricity generation um, fuel mix, you can find that coal, even in 2019, coal was sharing 36.7% of the fuel, and uh, solar power, solar ventures and many of the solar plants came on live onto the earth, and those were added to the national grids. Yet after that, it was only 2.7% of the whole energy mix in regarding the electricity generation only. So these these values tell us that coal is not going anywhere soon from the earth. So we have to find a way out, find a sustainable way out to live with coal for a while, until and unless we find the best alternatives for the civilization growth. So from that perspective, the IPCC, the Intergovernmental Panel for Climate Change, and IEA, International Energy Association, these these forums of United Nations. Along with the United Nations, they had the major guidelines to cope up with the best scenarios that coal can actually offer. And uh, let's start with a video presentation. What uh, Thailand has planning. Also, they have also they have also the dependency on the coal. So they had to care for the uh, uh, coal nuisances, which is very much prominent. So they have the concern, and they are building plants. They are building plants uh, which are clean coal technology friendly or something. So let's start with the basics of clean coal technology. What do they say?
The demand for electricity is rising every day. 70% of fuel used in Thailand's electricity generation is natural gas, which is a fuel source that will be used up in the near future. While alternative energy like solar power, wind power, and hydropower cannot be used as the main energy source to generate enough electricity to fulfill people's needs. Under this circumstance, we may face an energy crisis. Electricity Generating Authority of Thailand, or EGAT, then has conducted research and sought for energy sources to be used in secure electricity generation. It has been found that coal is the fuel that is suitable to ensure energy security in the future. Because coal reserves are plenty and can be used to produce electricity for a long time. Electricity Generating Authority of Thailand has also selected clean coal technology, a proper technology that provides environmental management system. The power plant using clean coal technology is the proper answer to the energy security, as well as the environmental management. Humanity needs happiness. It cannot be denied that electricity is a type of energy that helps create the happiness in life. Shall we take a little time to learn about the advantages of this clean coal technology power plant? Before we get to know the clean coal technology power plant, let's learn about the coal we will use to generate electricity. Electricity Generating Authority of Thailand will import the high-quality coal from overseas, including subbituminous and bituminous, which provide high calorific value and low sulfur content. The coal will be transported by sea in a closed system, heading to Banklongruwa port. A 10,000-ton cargo ship will deliver the coal of only 8,000 tons per trip. The shipping is done 2 ships per day and only in the daytime, following the timetables of Hydrographic Department, Royal Thai Navy, with the vessel speeds not more than 20 kilometers per hour. Once the coal cargo arrives at Banklongruwa port, the next step is to transport the coal to the power plant via conveyor belt, by using the screw elevator to suck and transfer the coal to the conveyor belt. This process will be conducted in a closed system to prevent coal dust emission. Coal transportation route in the closed conveyor system from the port to the power plant is about 8.7 kilometers. The first 2 kilometers of the coal conveyor partly covers mangrove swamps and natural canals. Electricity Generating Authority of Thailand has kept in mind the importance of the environment and the society and came up with a transportation design for this part to be conveyed through the underground tunnel in a closed system, under the depth of less than 30 meters to minimize the effects on nature. After that, the coal will be conveyed through a closed system at the ground level, with a distance of 6.7 kilometers to the power plant. Public roads will be built for the benefit of the people in the area. Sound barriers will be constructed, while trees will be planted to be the sound-absorbing front for the nearby communities. Moreover, in case the conveyor has to cut through any existing roads or canals, the conveyor will be elevated. More U-turns will be built, and in some areas, footbridges will be constructed. Generating Authority of Thailand has implemented the control management system and the technology that is modern and friendly to the environment and the community. Clean Coal Technology Power Plant of Krabi is a modern power plant with an environment concern technology. We apply ultra supercritical technology, which is the technology that escalates the overall electricity generating procedure more effectively, comparing to the previous technology. Therefore, we can reduce the level of fuel consumption. There are many steps in the electricity generating procedure, starting by transferring the coal into the coal pulverizer. Which grinds the coal into powder, then blows it along with the air into the combustion chamber. When the coal burns, the heat energy is released and transferred to the water in the pipes around the chamber's wall. That increases the water temperature to the boiling point and becomes high-pressure steam. Then, the steam will accumulate through the pipes the steam turbine mounted to the generator. This will rotate the shaft mounted to the generator. The magnetic field will circle through the coil inside and generate the electricity. The steam that passes through the steam turbine will go to the condenser. And transfer the heat to the water in the cooling system. The steam is then condensed back into water. After the steam becomes water, it will be boiled into steam again in the combustion chamber to re-spin the turbine. The overall cycle takes place in the closed system. The cooling system is used to condense the steam from the electricity generation into fluid for repeated use. The cooling tower takes the outsourced water to exchange the heat with the steam in the condenser. This increases the temperature of the cooling water. Then, the water needs to be passed to the cooling tower to lower its temperature by emitting the steam. Moreover, the water will be taken to the reservoir to adjust its temperature as close as the temperature of the water source outside before it is sent back to the natural water source. The ultra-supercritical technology we have chosen helps increase the efficiency of the power plant's environmental management and removes mass pollutants in the air to be below the legal measure. The management procedure on the contamination of oxides of nitrogen, mercury vapor, mercury-contaminated dust, lead, arsenic and cadmium, and sulfur dioxide is done in the following processes. In removal process of oxides of nitrogen or NOx with SCR technology or selective catalytic reduction, NOx will be removed first by spraying ammonia to react with NOx through catalyst and be separated into water and nitrogen, which are the main components in the air. NOx is now removed in this process. The next step is the mercury vapor collection. This helps remove mercury more than 90% by using activated carbon injection technology, or ACI, that injects the carbon to absorb the existing mercury vapor. The powdered coal then disperses with other dust and mass. The next process uses an electrostatic principle called electrostatic precipitator, or ESP. This method applies the principle of electric potential difference to induce the dust and fly ash to negative charge and induce the collecting plate to positive charge. This makes the dust and fly ash flow to accumulate on the collecting plate that will be kept in the silo within the power plant's area, prepared by Electricity Generating Authority of Thailand. Lastly, sulfur oxide is removed with flue gas desulfurization technology, or FGD. The water mixed with ground limestone is sprayed from the top to react with the floating sulfur oxide, contributing to the production of gypsum. As you can see, electricity generation using the CleanCo technology also offers byproducts, including bottom ash obtained from the coal burning process, as well as fly ash and gypsum, obtained from the air mass reduction technology used during the burning process. Moreover, these byproducts can be used in industrial sector to further drive the economy. With a dedicated commitment in exploring and researching on electrical energy, Electricity Generating Authority of Thailand believes that the CleanCo technology power plant can be practically implemented and will be an alternative that can create energy security. With a procedure that is clean, safe and friendly to the environment and the community, with good management and ability to generate electricity efficiently. CleanCo technology is a suitable alternative that can generate the greatest benefit for the sustainable energy for everyone.
Okay, so are you there, everybody? So that was the okay. So that was the cartoon, and that was the initiative that Thailand is taking up. But at the end of the session, I will show you another video clip from a Canadian power plant which has implemented these things from 2015. So there are already plants around the world who are taking up these techniques for in the name of clean coal technology. So those things, the SCR, selected catalytic reduction, which uses for NOx removal. The ACI, which is activated carbon injection technology for mercury vapor removal. The electrostatic precipitator for removing the particulate matters, for the flue gas desulfurization uh, uh, part, which removes the sulfur oxides. So these are some of the techniques, some of the many techniques which are used in the power plant, with the power plants to reduce the emissions or to capture the emissions from from coal. So this is how the clean coal technology works. But let's get into further details about clean coal technology. There are some reviews and some data. I have already deposited some very important illustrations and the books review works from International Energy Agency and BP, the World Energy Outlook, and of course about CCS. We will come to that thing in a while. Carbon capture and sequestration. So about the latest updates, there are some 2021 data also. So those books are deposited in the Google folder. So you can access those and can read further. So this slide shows that from 2014 to 2019, the annual global energy consumption uh, 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 was increased, of course, increased, but coal dominance was little bit reduced. But you see that solar and gas, oil, all these things surged up, and yeah, and this is a good indication, of course, from the climate change perspective, from the global warming perspective, that that coal production is going down, but other intensive energy sources are coming up in the queue to support the green technologies. And this slide says that at the global level, still coal is the dominant fuel for power generation. We just saw one of the previous slides that in the power generation mix, the coal dominates actually. Even in 2019, it was around 37%. So, but its share fell by 1.5% to 36.4%, around 37%. It actually fell from the previous year by 1.5 percentage points. So, and this is the lowest level in this data series. If you can look at this is the lowest level in from 1987 to 1991, as 2019, from 1987 to 2019 data series. This is the lowest level. So coal share finally fell down to 1.5%. This is a good indication from the environmentalist point of view. And the thing which I just said, that the shares of both natural gas and renewables rose to record levels last year in 2019 actually. So natural gas by 23.3% and renewables rose by 10.4%. And renewable generation surpassed nuclear for the first time at this point. So this is nuclear and this is renewables. And some coal statistics and what is coal used for? Coal is used to make plastics, tars, and fertilizers, and a kind of coal derivative, a solidified carbon, which is called coke, that is able to melt the iron ore, and it can reduce the iron ore to create steel. But most of the mined coal actually goes into the power production. In USA, one of the biggest power consuming power and energy consuming countries around the world, uh, they use 92% 92% of their the 92% of their electricity fuel mix as coal. Actually, they use coal for electricity generation, and its share is 92%. So this shows us that how coal is being used around the world, and the coal reserve is huge around the world, which we said that it's plentiful and it's very abundant. It's readily available, uh, and this energy intensive resource is 1,070 billion tons. It's almost it's almost uh, uh, this can be dug out. This is proved plus probable reserve base. So and and there are more than 70 countries who have coal deposits in their undergrounds, but over 50 countries they are commercially mining coal actually. And China is the largest producer. Uh, they have produced 3.7 billion tons of coal in 2019 only, among 8 billion tons of coal uh, in the whole world. So uh, and that for the world record in 2019, 8 billion tons. That is a 70% increase over a 20 years span since 1999. So it shows that how the coal dependency is growing day by day, has been growing day by day, and globally, this coal industry directly employs over 7 million workers, which creates millions of indirect jobs also. And so there's a substantial social economic impact of coal mining industry. And these things, I don't need to say these things again. I think previous uh, instructors, they already have shown these things in very detail, that the fuel contribution in the GHG global greenhouse gas emission perspective. So yeah, this is another thing. You see that it's a 38 gigaton of carbon dioxide was released into atmosphere in 2019, and that was a 0.9% increase from 2019, and the previous year in 2018 it was a 1.9% increase from the 2017. So and the major share we can see this is from coal in 2019, and the preceding years also, the preceding few couple of years. So yes, coal has this problem. Coal has to clean its image if it really uh, has to be exploited onto the earth. And this is another scenario. How the what is the growth rate from 2014 to 2019 in these 5 years? You can see that it's a little bit optimism that from in the last 5 years, from 2014 to 2019, it actually fell. The world's coal demand actually fell by 0.6%. Uh, there is a very important thing which you saw in the video clip, that there is a coal rank, and the precursor of coal is actually peat. Peat is not coal. After peat is uh, uh, subjected to higher temperature and pressure condition into deep subsurface, then the coalification process starts, and the coal classes on the or the grades are these. You see that low rank coal, medium rank coal, high rank coal. So these have defined calorific values, defined volatile matter, percentages, and fixed carbon, of course. So these things define that how mature is the coal and how harmful is the coal, if you think of from that perspective. If it's a low rank coal, if it's lignite, if the calorific value is low, that it means that it has more volatile matters and the moisture content is very high. So this will exert much more emission than the higher rank anthracite coals. So this is the basic. You can use this table from for knowing the details of these specific coal ranks. This is called coal rank or coal types also, and or also coal grades, and they are sold at different prices, of course. And coal mining. The history of coal mining goes back thousands of years, of course, from the early civilization. Mm. And but since 1880s, it has been primarily used to power steam engines, heat buildings, and generate electricity. Steel industries use coal as a fuel for extraction of iron from iron ore, and cement industries for cement production. So these are the major uses of coal in the historical time frame. And yeah, it's the coal mining is still continuing at a full pace. And the conventional mining methods, we many of us we have heard about underground mining methods and surface mining methods. So this is a combined composite picture. Uh, uh, it says that the surface mining methods are this stripping methods, which is mountain top mining, the contour mining, the high wall auger mining, and area mining. And there is underground type of mining, which is slope mining and shaft mining. So we have to do the shaft and just just move under the subsurface, move underground. So the important thing that seems relatively close to the surface at depths less than approximately 55 meter, less than approximately 55 meter or 180 feet are usually surface mining. But over that, over 55 meter, usually underground mining is thought to be yeah, prosecuted. So what is a surface mining method? I have shown you that illustration. So this is also called mega mining, open cast mining. And one example was how what might be the extent of open cast mining. So the world's biggest open pit mining is which has a 1.9 billion tons of probable proved and probable reserve. Within that 1070 billion tons of world reserve. It's almost containing 2 billion tons of reserve. So this North Antelope Rochelle coal mine, it is in Wyoming, USA. It started in 1999 and it was lying at a depth of 100 to 150 feet. And up to 2019, it already produced 85 million tons of coal. So this is the extent of surface mining. So this is a picture. This is a picture from Australia. You can understand how these are called benches. So you have to make gullies and benches to reach successively to the bottom of the coal seam, and you have to cut the edges. So this is how, and the vast area has to be evacuated. No other land use are allowed here, like no settlements, no cattling, farming, or no agricultural lands. Nothing can stay here. during the mining. And after the mining, usually the land is reclaimed. Uh, that is usually uh, converted into a pool or something like this for another kind of land use, not to the pristine situation. After a surface mining is ended, and the subsurface or underground mining. So this is the worst, most common way to extract the coal resources from the earth, and this accounts for about 60% of world's coal production, though this is a bit risky. So there are health and environmental issues relating to the conventional coal mining methods. There are severe health effects caused by burning coal. According to the report of WHO in 2008, coal particulates pollution are estimated to shorten 10,000 lives annually worldwide. And when compared to electricity produced from natural gas, coal electricity is 10 to 100 times more toxic, largely due to the amount of particulate matter emitted during combustion. So when coal is burnt, the particulate matter of fly ash is moving into the air. And yeah, so uh, and underground mining hazards like suffocation, gas poisoning, roof collapse, these things are very common in the underground coal mining scenario. Open cut hazards are principally mine wall failures and vehicle collisions. In the United States, an average of 26 coal miners per year died in the decade from 2005 to 2014. And another problem is the coal refuse or waste. After the coal is used, then managing these tailings is a problem. So these are usually uh, piled up, and but statistics, statistics something like that. For every ton of hard coal generated by mining, 400 kilograms of waste material remains. So around 40% waste material, which include some lost coal that is partially economically recoverable, and coal refuse is distinct from the byproducts of burning coal, such as fly ash. So this is not fly ash. This is a different thing. And these files may have significant negative environmental consequence. Uh, this can There can be iron leachate, manganese, and aluminum residues into waterways, and acid mine drainage can happen. So this runoff can create both surface and groundwater contamination. So coal refuse or tailings, those have serious concerns. So let's get into the thing, what is clean coal technology? How do we define it actually? So uh, when the coal burns, uh, it releases carbon dioxide, flue gases containing sulfur dioxide, nitrogen oxides, particulates, others. So and this is very much visible. We all know this scenario. We have seen this picture. We have seen this scenario every now and then. So this is a billowing clouds pouring out of the chimneys, and and uh, these are those things, those flue gases. This billowing cloud is containing those flue gases. So presumably, clean coal technology deals with these harmful gases and particulates. This is supposed to, clean coal technology is supposed to remove or reduce them before letting go into the atmosphere. So how do we define clean coal technology? So these words, clean coal has been around for years only, but there is an official definition which was stated in US Senate Bill 911 in April 1987, more than 30 years ago. So it says that the term clean coal technology means any technology deployed at a new or existing facility which will achieve significant reductions in air emissions of sulfur dioxide or nitrogen oxides associated with the utilization of coal in the generation of electricity. So that's how we defined clean coal technology. And if you look into the definition, there are primarily two concerns. So firstly, clean coal technology is mainly thought to be related to the deployment of coal-burnt electricity generation facility. So this was thought to be related with the electricity generation, coal-based power plants. So, and the other concept is that the air emission reduction technologies associated with those electricity generation facilities or power plant, which you saw moments ago in the video clip, that there were selected catalytic reduction or SCR, there were SCI, activated carbon injection technology, there were electrostatic precipitators, there were flue gas desulfurization device attached. So those things are the second factor stated in this definition. They say that these technologies associated with those facilities have to be there for being a clean coal technology. So that's how we defined clean coal technology. But after more than 30 years nowadays, it is not only related to the deployment of coal-burnt power plants, coal-based power plants. The scientists have also extended clean coal technologies towards a very promising horizon, which include technologies that capture and store carbon dioxide. It's called CCS, carbon capture and sequestration. The world is very much excited to take up those projects. I will come into that thing in a while. So these things already have been illustrated in that video clip. I will just utter the key terms: coal washing, which removes unwanted minerals by mixing crushed coal with a liquid. What you saw that there were pulverizer. So pulverizer do that thing. Coal washed and coal powdered to feed the plant. Then that wet scrubbers of FGDs and that low NOx burners or SCR, selected catalytic reduction device, electrostatic precipitators, and there are coal gasification technology, which I will discuss a little bit elaborately because that's my area of research actually. So steps in a coal-fired power plant. You already saw in the video illustration, but yeah, there are those are also numbered here for your convenience. One important thing is that in a coal-fired power generation, still till today, is only 40% of thermal energy in coal is converted to electricity, and 60% efficiency is lost. So that's how we define the efficiency of a power plant. So 40% thermal energy is used to produce electricity, and 60% goes into just emissions. So that's how we lose the efficiency. And there is a silly calculation. There is around 2,460 kilowatt of electricity generated per ton of coal. A standard 500 megawatt coal power plant produces 3.5 billion kilowatt hour per year. Uh, I will show you the video clip later on. Now should we take a break now for 20 minutes, ladies and gentlemen?
Yes, sir.
Okay, sir.
Okay, so it's 20 minutes break from now. Thank you so much. See you again. Hello there. Everybody here? Can I start?
Yes.
Thank you, Ms. Jara. So Mr. Harmawan asked one question. Why don't utilize carbon capture technology? Yeah, so we are coming into that thing now. Uh, Carbon capture and sequestration technology, so which is very ambitious, and the world is just getting into this thing now. Though the research has been over 20 years, I guess, we'll look into those things. But still, the uh, cost related to CCS is very high. So it's difficult for taking up this thing or patching this up with any like retrofitting or just building new plant with CCS is still not viable. But countries are looking into that. There are incentives. They are incentivizing the process, and the CCS is very fast is getting popular. We'll look into that thing. So. Uh, So all of the fossil fuels, like natural gas, oil or coal, when they are burned for energy production, they emit carbon dioxide, the heat trapping gas, which is the main cause of global warming. And uh, from the statistics, like natural gas produce 50 gigajoule per ton, crude oil 45 gigajoule per ton, and coal 29 gigajoule per ton of energy. Uh, eh, it shows that the coal releases the highest carbon dioxide when burnt for energy. So we just cannot uh, release these harmful carbon dioxide into the atmosphere uh, for getting it warm and warmer. So there is the ambitious strategy of all clean coal technologies. The strategy is to catch and sequester the carbon dioxide emission from stationary sources like the power plants. And there are some technologies evolved after many years of research. So those are the flue gas desulfurization process, flue gas separation, uh, which actually removes carbon dioxide with a solvent, strips off the carbon dioxide with steam, and condenses the steam into a concentrated stream. Uh, uh, there is oxy-fuel combustion, which is mainly burnt in purer enriched oxygen uh, uh, instead of air and water. So, and there is pre-combustion capture, which removes the carbon dioxide before it's burnt as a part of the gasification process. So a little bit detail of oxy-fuel CCS operation. So this is the typical plant, and uh, this was actually implemented. This this was actually implemented in 2008 in Germany. This design, this was a pilot carbon capture and sequestration project in conjunction with the power plant. It was the first coal-fired power plant in the world which actually adopted this technique. So, if we capture the carbon dioxide and what do we do with them? There is this thing that capturing carbon dioxide is expensive, but there are ways we can actually make it cost effective. Like we can utilize and we can store in an inexpensive way. So what are those options? So after capture, secure containers, so the containers can collect the carbon dioxide to prevent into the atmosphere. There are those can be directly stored, of course. There are two kind of storage options, which is geologic and oceanic. I will show in an illustration in a moment. So uh, the uh, the theme is that these storage options must contain the carbon dioxide until the peak emissions subside hundreds of years from now. So, uh, and geological storage involves injecting carbon dioxide into the earth. Uh, and there is a cost-effective mechanism that we can do this. We can work with this captured carbon dioxide. We can utilize them for enhanced oil recovery. So those oil fields or gas fields which are already depleting, which are going to be diminished soon, those can be boosted up further. So either in enhanced oil recovery or enhanced gas recovery methodology. So this carbon dioxide can be actually injected into the reservoirs, gas reservoir or oil reservoir, and that can boost up the production one more time. And the depleted oil fields or gas fields, that those can store, those can be used to store the carbon dioxide. And of course, there are deep saline aquifers also, which are vast and which are much more in space than the depleted oil or gas fields. So, and there is ocean storage. Technology still in its early stages, involves injecting liquid carbon dioxide into waters 500 to 3,000 meters deep, where it dissolves under pressure. However, this method would slightly decrease the pH, and potentially this can harm the marine habitats. There is this downside, of course. And all forms of carbon dioxide storage require careful preparation and monitoring to avoid creating environmental problems. So I told you that CCS, CCUS, these are still in the research and development phase. And this is the thing I meant. So IPCC, Intergovernmental uh, 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 Panel of Climate Change, that they have illustrated this thing in their 2005 that in 2005 report. They have mentioned these options. This is geological storage options, and you can see that there are depleted oil and gas reservoirs. There are they have mentioned other options also, that use of carbon dioxide in enhanced oil recovery, deep unused saline water saturated reservoir rocks, deep unminable coal seams. That is one of the options I am looking into for my research. And use of carbon dioxide in enhanced coal bed methane recovery. So that's some kind of that's a little bit similar to EOR technology, enhanced oil recovery technology. So coal bed methane recovery can be boosted up by injecting carbon dioxide also. And yeah, so and this is another illustration from the same IPCC in 2005. So it's a CCS system is showing that the carbon sources for which CCS might be relevant and options for the transfer and storage for carbon dioxide. This figure illustrates that thing a little bit in detail, that there is electricity generation, there is cement or refineries, there are petrochemical plants. So these will produce the carbon dioxide, but that carbon dioxide can be stored or can be used in the industries for mineral carbonization, for industrial uses, and this can be stored in the geological storages or in the ocean storages, deep saline aquifers, something like this. And I will go into the IPCC in the CCS report in a while. From there, we can see the updates and upgrades of the technologies and the country initiatives of CCS so far. But in brief, carbon capture, this technology CCS helped capture 40 million tons of carbon dioxide in 2020 from its 26 operating power and industrial facilities globally around the world. Uh, excuse me for a while. So this is the global status report of CCS 2020. There is another very important thing the world is seeking for. It's net zero carbon by 2050. So that is the target. Might be a little bit ambitious target, but the world is really looking into this thing to save the earth. So it's something like I have highlighted some parts, like the time is running out to reach net zero emissions and limit temperature rise to 1.5 degrees centigrade. Although COVID-19 crisis has resulted in unprecedented reductions in energy demand and emissions, the long-term picture for CCS has not changed. To have the greatest change of chance of achieving net zero emissions, it is essential that wide use of CCS happens quickly. It's the assessment of this report. There are 4 scenarios you can look into. There are 4 scenarios. The need for CCS, why CCS is urgent. It's described here. So it presents 4 scenarios for limiting global temperature rise to 1.5 degrees Celsius. All require carbon dioxide removal and 3 involve major use of CCS. So if you look into detail of this picture, you will find that CCS is urgent for the earth. Global CCS facilities update and trends. So this is the worldwide CCS ventures and practices around the world. The red color is the commercial CCS plants, facilities which are in operation, and the blue color is the in development, commercial, but CCS facilities in development. So like this, we can see this thing. So there are 65 commercial CCS facilities around the world. 26 are operating, and others are in some kind of development or in construction phase. And CCS facilities currently in operation can capture and permanently store around 40 million ton of carbon dioxide every year. What we just wrote down. There are around 34 pilot and demonstration CCS facilities in operation or development, and 8 CCS technology test centers. So worldwide, the concern is rising. If CCS is used in conjunction with the coal gasification plant like CCGT, like closed, what is that? Combined cycle gas, combined cycle power plant. If where coal gasification is used for generating electricity, if you can use this in conjunction with CCS, that can also produce commercial hydrogen, and this is considered as the fuel of the future actually. This is also an important table. It says portfolio of commercial CCS facilities in various power and industrial applications. Facilities include those in operation, under construction, and first development. Area of circle is proportional to current CCS capacities. So the capacity can be understood from the magnitude or for the size of the circles, and the names are here. And what are the purposes? It's written here: cement production or power generation, coal. This is a very good table. This report constructs very important updates of CCS around the world. The Intergovernmental Panel of Climate Change, their meeting is postponed. The next conference of the parties, COP26 of the United Nations Framework Convention on Climate Change, has been postponed for a year to November 2021, this year's November. So they have some very important issues. One of them is getting the implementation of the Paris Agreement up and running, and finalizing the Paris Agreement rulebook, of course. Geological storage options. This is about global storage. So geological storage of carbon dioxide uses the same forces and processes that have trapped oil, gas, including the naturally occurring carbon dioxide. So naturally, some carbon dioxide is also entrapped or trapped, or it's compressed under the extensive pressure in the subsurface. So no need to worry about those stored carbon dioxide to escape away actually. So because the same way the earth has hold the oil or gas for millions of years, the same force will bind the carbon dioxide into the rock into the rocks pore spaces. So that's how it will be secured actually. And one important thing, one very important thing is that the blue colors you see, these blue colors are the uh, saline formations, so these are the saline formations around the world, and these can hold carbon dioxide very efficiently. So geological storage options like the depleted oil fields, gas field, or some used coal seams, those are not that much widely spread like these saline formations. So from this picture, we can understand that there are there are there are huge spaces to store the carbon dioxide. It says here that geological storage resources for carbon dioxide in saline formations is hundreds of times larger than the resources of oil or gas fields shown in this figure. So this is the thing, saline formations. And so from here, this is a status update that these countries with a storage resource catalog, these countries, United States or UK, they have this uh, undiscovered undiscovered storage potential, and they have some sub-commercial, and the capacity in red color, and actually stored in this color. So it says that United States have 7,000, almost 8,000 uh, 8,000 gigaton of carbon dioxide equal space. So storing space is undiscovered in USA, but they have within that 8,000 gigaton of carbon dioxide storage potential, 258 is sub-commercial, and they have a capacity. Uh, they have a capacity of 0.004 gigaton of carbon dioxide storage potential right now, and uh, uh, and within that storage potential, they have already stored 0.003 gigaton of carbon dioxide within those options, within those global within the storage options. So that's how. And China has also a big storage potential, and they have stored some also. From this table, you can find out what is happening. The executive director of IEA says that reaching net zero emissions will be virtually impossible without CCUS. So it's a warning. And regional overviews, I have marked many things. So USA is far ahead than any other countries in developing and in researching, in terms of research also in carbon dioxide capture and sequestering usage matters. So they already have 38 commercial facilities in operation. There are many in queue, and Canada also, and yeah, and there are updates of all the world. Europe has 11 commercial projects, 13 commercial facilities in operation, and more than 11 commercial projects are targeting operating before 2030. So there are projects in queue. Asia Pacific, uh, uh, in Asia, in our Asia, 10 commercial CCS facilities either operating or in various stages of development. And the countries that have started establishing their CCS strategies as part of their long-term climate change commercial commitments include Singapore, Malaysia, China, Australia. So uh, they have incorporated the strategies in their policies, something like this. So Thailand is also in the key hub for CCUS, carbon capture, utilization, storage. So so from this report, if you go through in detail, you can have many information about the commercial CCS ventures around the world. I think it's a very helpful report. I have stored it into the general space. You can find it there. So I think I will show you those things briefly in another video clip. This is a cartoon video clip, another good one I found in YouTube.
What lights up the screen that you're looking at right now? Trace back the battery chargers and power cords, and you'll end up at an electrical outlet, providing easy, safe access to reliable electricity. But beyond that outlet, the picture gets messier. It takes a lot of fuel to heat our homes, preserve our food, and power our gadgets around the clock. And for 40% of the world, that fuel is cheap, plentiful, and it's called coal. But coal also releases pollutants into the air, like sulfur dioxide, nitrogen oxides, soot, and toxic metals like mercury. These cause environmental damage like acid rain and serious health problems. In fact, in 1952, coal burning caused such heavy smog in London that pedestrians couldn't even see their feet, and thousands of people died from ill health. Since then, many countries have deployed technology to remove most of these pollutants before they reach the air. But now we have a new air pollution problem on our hands, one that doesn't show up in a cloud of dark smog, but in rising seas, floods, and heat waves. It's global climate change. And again, the main culprit is coal. It's responsible for 44% of global carbon dioxide emissions, which trap the sun's heat in the Earth's atmosphere instead of letting it escape. So now the question is, how do we remove that bad stuff as well? That's the idea behind cleaner coal. Creating cleaner coal is really about trying to contain its ill effects with the help of special technologies that make the end product more acceptable. Just like the most intriguing superheroes often have their own dark powers to overcome, so we can try and keep coal's negative forces in check. But why don't we just exterminate coal if it takes that much effort to clean it up? Simply, coal is extremely valuable to us, and it's easy to come by. Compressed underground for ages, coal holds chemical energy from plants that were fed by the sun hundreds of millions of years ago, long before humans evolved. That makes coal energy dense, meaning it can be burned round the clock. It's also cheap if you ignore the pollution costs, and should last us through the end of the 21st century. We've already got all the infrastructure in place for harnessing its power. And globally, although countries are making a move towards energy from cleaner and more renewable sources, there's no sign yet that coal use is slowing down. In fact, as of 2012, over 1,000 new coal plants have been proposed, mostly in China and India. Since, for the time being, coal is here to stay, experts say that if we want to reduce its emissions impact on the atmosphere and slow down climate change, we'll have to think of creative ways of reducing coal's destructive power. To do that, we need to strip it of its foul forces, all that toxic carbon dioxide that causes havoc in the atmosphere. Then we need to store this CO2 somewhere else. This mission is called Carbon Capture and Sequestration, or CCS. And as if carbon dioxide were some evil genie we didn't want to escape, once it has been separated from coal, we've devised ways to banish it underground. We can do this by injecting it deep into the earth, or by placing it deep under the ocean's surface. Stripping away coal's negative elements can happen in three ways. First, and most commonly, as coal burns, the exhaust gas can be mixed with a compound called monoethanolamine. Like a forceful power-stripping magnet, this compound bonds to the CO2, yanking it out of the gas stream so it can be stored separately underground. Another method is to relieve coal of its CO2 before it even has a chance to be released as exhaust. In this process, steam and oxygen swoop in to the rescue to convert coal into a special product called syngas, made up of carbon monoxide and hydrogen and some CO2. Zap that with some water vapor, and the carbon monoxide gets converted into carbon dioxide, which can be isolated. The leftover hydrogen gas is then used as energy to generate electricity, so there's an added bonus. A third technique exposes coal to pure oxygen instead of burning it in air. This creates exhaust gas with higher concentrations of carbon dioxide, which makes it easy to isolate and to banish to the chasms below. All this can reduce emissions at a power plant by up to 90%. But as with any superhero struggling with their destructive powers, it takes a lot of effort to switch over from the dark side. So these positive pollution-busting forces, although they're available, have barely been used in commercial power plants because they cost a lot. But ultimately, the bigger problem is that in most parts of the world, it's still too easy and much cheaper to keep emitting carbon dioxide. And that makes it tempting to completely ignore coal's dark side. In this case, the most powerful force for good is regulation. The rules that can restrict the amount of carbon dioxide emitted from power plants and make energy companies around the world wary of what they put into the air. Until then, every time you turn on a screen or flick a light switch, coal is lurking in the background, carrying its dark powers with it wherever it goes.
So here we are. Uh, so those are all the things that clean coal technology deals with. But there is a second thought. After all these things, the dispute still remains that if the coal is burnt on the surface facilities, if the coal is dug out on the surface and it is burnt in the surface facilities, whether it is combined cycle power plant or just some kind of entrant flow gasifier or fixed bed gasifier, what engineers use for doing biomass or fuel burning, those facilities. So whenever these coal is burnt on the surface facilities, there are the environmental nuisances taking place anyway. So there's no escape of those coal dusts, those havocs which we have seen in several instances now. So, is there a way? There comes the question: is there a way that we can harness the energy from the coal resources directly from the underground, directly in situ? So, can we bring out the energy from coal without even bringing it out on the surface, without burning it on the surface? So, if that can be still kept into the underground reservoir in situ, and we can just bring out the power or the energy within it without digging it out, the environmental problems can be dealt to a many to a good way actually. So that is the thing, that if there is no mine working in the underground for extraction, many of the mine related accidents and fatalities can be avoided also. And there is no handling, no washing, no transportation. So there is no ash problem also. So because of not burning the coal, on the surface, the environmental issues are greatly proclaimed by those comparatively newer. So there are some new inventions of harnessing the energy from coal. So I'm here to talk about that. So it is now a timely demand now to exploit the vast coal resources lying out there in the subsurface. So we have to get that energy out of the subsurface, but in a sustainable, controlled manner. So newer options are there. We don't have to get out all the coals out of the subsurface. Let it remain there, but we can get the energy from there directly. There are options. Those are called unconventional coal mining methods. So you may have already heard about coal bed methane, or it's also called coal seam gas or coal mine methane. So which is actually entrapped methane gas in the matured coal layers. So there are coal, these fractures in coal, these are called clits. So in these fractures, there are methane gases entrapped, and that can be harnessed uh, by the same way as the gas, as we explore the gas, actually natural gas. So, and this has been a very popular method of harnessing energy in United States, in Canada, in Australia, and many other countries. So coal bed methane is a really savior project without burning the coal, without taking out the coal. Uh, the matured coal, which already have produced methane entrapped within them, that can be just harnessed through the gas extraction facilities, and that is somewhat more pure than the conventional natural gas. So this is a better thing. And there is a picture of the CBM reserves. Problem is that CBM reserve estimates cannot be readily calculated. Difficulties arise from the fact that only a fraction of coal reserve is counted in estimating the CBM reserves. The whole coal reserve is not taken into account when CBM reserves are being calculated. So that's why the reserve is not true to the scale. But still, you can find out that these countries, USA, combined with Alaska, and this is 137 trillion cubic feet and 701 trillion cubic feet. And Canada has a very good reserve also. Russia has a very good reserve. China and Australia, they have very good, very, very good reserves of CBM. And these reserves can feed them with clean fuel for years. For years, they can they can enhance the extraction methodologies, extraction of these CBMs straight away. And one estimation is that CBM provides about 7% of total natural gas consumption in the USA. So they can really enhance the production from CBM more and more. And there is the biotechnology in coal reserve. Uh, the second method I will talk about is uh, that this can be applied for coal energy extraction without digging out the coal or without excavating the coal on the surface. This can be done through defined ways: desulfurization, degradation and solubilization, liquefaction, and gasification of low rank coals. So one condition is that has to be a low rank coal, so which is very much abundant around the world. So the most of the coals lying in the underground are low rank coals. So this is a better way. And the comparative non-destructive conditions of coal bioprocesses make this method preferable over conventional thermal technologies, which require a great deal of temperature again. And the advances in research of bioprocess technology offers lower processing costs, flexible processing conditions, and cost-effective commercial scale microbial processes. Coal is undergone degradation and solubilization process synergistically by defined microbial metabolites to produce high value products like methane, methanol, etc. And from technical feasibility viewpoint, coal biodesulfurization is an example of a coal bioprocess with inorganic sulfur removal rates up to 90%, which is amazing and which cannot be attained by any other processes, any other coal, the coal burning or coal energy harness processes. So this can be attained up to 90%, though the removal of organically bound sulfur has not been convincingly demonstrated yet. So besides, from economic perspective, the method is not yet favorable due to the higher energy demands in reactor systems. So it's still under research and development. So it's highly recommended to initiate research and development in this field of novel conversion technologies. This can just diminish many of the environmental problems straight away. And there is another technique called borehole hydraulic coal mining system. This actually, this is a little bit different. It brings out the coal on the surface, but the way it brings out is this almost do the first stage of clean coal technology, like the washing and cleaning of the particulate matters are readily done in situ. So the way it's done is it can be seen from this figure that there is a slurry around the borehole in the coal seam layer here. So this is remotely operated from the surface. It can be from the surface, from open pit floor, from a floating vessel, through pre-drilled boreholes. So this is accomplished through fragmentation of coal seams and subsequent removal of coal slurry through the drilled hole using high pressure water jetting, or what is called hydraulicking or hydrofracking, hydrofracturing. So, but this borehole hydraulic coal mining system is also still under research and development phase. So it still needs to go up to some scientific breakthroughs. And the last unconventional coal mining method, I want to emphasize on this part a little bit more. This is underground coal gasification. There are the most of the CCT, coal clean technology methodologies deal with the surface coal gasification methodologies, like bring out the coal first on the surface, then burn it by pulverizer to the pulverizing. So crush it into powder and then burn them, and then try to omit the emissions from burning of coal. But through this method, underground coal gasification, there is no digging out of the coal, no excavation of coal. So this is a thermochemical process. This is which is done in situ. So coal gasification is done underground, and so the only thing is that this has to be carried out in non-mined coal seam, which we are not mining the coal seam, using injection of oxidants and steam. Oxidants mean oxygen plus water, or might be air plus water. So these are called oxidizers. So oxidizers are inserted through an injection hole, and then the coal coal starts combustion and subsequent gasification, and then the product, which is called syngas or synthetic gas, which is the prime component of which is hydrogen and carbon monoxide, and there are minor uh, methane, carbon dioxide, and some other constituents also. So that syngas, synthetic gas, is drawn out through a production pipe. So then then this comes onto the surface facilities, like a gas cleaning plant. So just the surface facilities are the gas cleaning plant. There is no coal handling, coal washing, coal transportation, and those kind of environmentally hazardous issues. So the gas cleaning plant uh, does the gas, separates the gases out. Carbon dioxide is captured, and it's used or is sequestered or stored, and so and it's used for electricity generation. The heat can be also used for thermal electricity generation also. So after over a century of laboratory and pilot experiences, so this technology is on the world for over a century. But as there is no human intervention, people don't have a direct control in the gasification or oxidation in the underground. There are some complexities, so those still have to be overcome through more researches. Uh, so and due to the cheaper price of oil and uh, gas and readily available uh, coal near the surface for open pit mining, this venture has never been very much popularized. But nowadays, there are lots of researches going on around the world, and that they have shown promises that this can be a savior project in the wake of the global warming and climate change concept. So uh, so UCG, if that underground coal gasification can be bind with uh, the CCUS, uh, there are manifold there are manifold advantages in terms of the carbon dioxide emissions. Okay, I will come to this thing, but just before talking about the carbon dioxide emission reduction methodology, I want to show you one video clip regarding the UCG methodology. That's a very excellent clip.
Underground coal. Underground coal gasification, UC.
We cannot see the video, sir.
Wait, please, Mark. I'm struggling to open it up. Ah.
Underground coal gasification, UCG for short, is a process in which coal is converted into synthesis gas while the coal remains deep underground. Syngas can be easily converted into liquid fuels,
Can you see
synthetic
anything? No.
natural gas, and
There's
for power
none,
No,
sir.
sir, we're not seeing anything.
UCG.
Wait, black screen. I don't know what is happening.
Underground coal gasification, UCG for short, is a process in which coal is converted into
It's only audio, sir.
I was struggling, and this computer doesn't have the compatible software, so I think I cannot open this up anyway. Okay, guys, I'm just sorry I cannot show you that thing. I was preparing that video for you. There is a very good illustration that how underground coal gasification, this thing, this is a very promising technology, and this can be a savior project in the long run. Actually, I wanted to show you that thing, but anyway, this is not running now. I hope I will give this video for your later exploring. So now I will just keep on going with this thing. So here I was that if we can combine the UCG, that is underground coal gasification, with CCUS, mean carbon capture, utilization and storage, then there are manifold advantages. The carbon dioxide emissions reductions are in many ways. So it's directly 25% lower than conventional pulverized coal combustion, and 18.6% of the carbon dioxide produced during UCG for carbamide production in the urea process. So you can take 18.5% of the carbon dioxide to produce urea fertilizer. So there are options to do a geological storage up to 16.3% in the geological storage options anyway. And UCG, I showed you in the previous slide that the oxidizers can be air or oxygen and steam, but carbon dioxide that can also be recycled as oxidizers, and if that can be done, then by recycling waste captured carbon dioxide as gasification agent again. So I will recycling, not using the oxygen or steam as oxidizer, using carbon dioxide as the gasification agent or the oxidizer, we can readily reduce 43% carbon dioxide by converting carbon dioxide to carbon monoxide. So we are making synthetic gas directly from the recycled carbon dioxide, and in situ carbon dioxide capture, so carbonate formation is possible, and 22% reduction of coal mined to produce the same amount of energy. So there is no necessity to mine the coal from the reservoir. It is 22% direct reduction. So these are the manifold advantages if we take the UCG venture, and if we can couple this with CCUS technology. And yeah, I have told you all these things briefly already. Two things, like UCG generates exclusive opportunities for carbon dioxide storage in the post gasification structures. So this is one thing, that the reservoir where you are implementing this idea, this technology, underground coal gasification, when the gasifier is spent, or when the gasifier is depleted, you have harnessed all the energies buried within it whenever you have done it. So you can exclusively use that place for carbon dioxide storage. So this is in the post gasification structure, and this is in geological terminology. I'm a geologist, so in this terminology it says that reactor zone carbon storage, and there are people who have researched on the feasibilities of reactor zone carbon storage options, and And other thing, I want to show you this thing again. So there is also a lower cost route if you want to reduce the expenses of the plant. There is a there's a lower cost route to the production of synthesis gas for chemical synthesis application. So the FT through FT method, Fischer-Tropsch transportation fuel uh, production methodology. So that way we can lower the cost more. And excess carbon dioxide always can be used to boost up the production of nearly depleted natural gas or the oil fields also, which you already saw, that enhanced oil recovery technique. And there is this thing, there is a cost assessment. Uh, Folks, do you want another break or just want me to keep go on like this? I don't have too many things to show you more, just this cost competitiveness.
It's okay, sir, if you finish it.
Hey,
For me, it's okay.
it's okay, Emily? Okay. So we can keep on going this thing, and then I will just invite you to come on the stage to talk about these things, what you think, what is your perception, and everything. Okay. Anyway, so let me keep on going. But if you want a break anytime, just tell me. We still have 40 minutes to go. If you want a 10-minute break at any time, we can go for it. Okay, let me check another 10 minutes. After 10 minutes, I will ask you again. Okay, so uh, this is a cost competitiveness from a different kind of plants. So you see that surface coal gasifier, I was talking about that there are fixed bed gasifiers, there are entrained flow gasifiers. So those gasifiers are extensively used around the world uh, for producing power, producing electricity from coal. So and if that is a integrated gasification combined cycle, so that can be uh, that can be used to create two forms of energy. So uh, with the integrated gasification combined cycle system, uh, at first the coal is burned, coal is burned, syngas is created, then syngas is burnt into a gas turbine to make electricity, and that is synthetic gas. And the additional heat with this synthetic gas production can be also used into the gas turbine to uh, to power a steam turbine. And so uh, this is the way IGCC power plants, or integrated gasification combined cycle power plants, create two forms of energy, and they have the potential to reach a fuel efficiency of 50%. So still now the fuel efficiencies around the world for the power plants are 45 to 46%. But uh, but we believe that UCG and UCG and in cooperation with the IGCC uh, and CCS, or carbon capture and storage, integrated technology that can bring bring those power plants efficiency up to 50%. And from this chart again, so surface coal gasifiers with shift and carbon dioxide. So shift reactions make carbon dioxide into carbon monoxide. Uh, so shift and carbon dioxide removal from syngas. This is very efficient in terms of greenhouse emission reduction. As a very very little greenhouse emission is done here from this plant, but you see the cost of electricity through this technique is very, very high. And this is a very welcoming technique around the world, natural gas combined cycle. So the greenhouse emission is moderate. It's 0.6 ton carbon dioxide per megawatt hour electricity. But the price is around $40 per megawatt hour. And you see that these three are the UCG competitiveness. If UCG is integrated with IGCC and with shift and carbon dioxide removal from syngas, the efficiency is the greenhouse emissions reduction is very potential, only around 0.3 ton carbon dioxide per megawatt hour, but the cost of electricity is high. It's around $50 per megawatt hour. And this one using untreated syngas, so you are not cleaning up the syngas, so that comes with all the impurities of sulfur dioxide, nitrous oxide, nitrogen oxides. These things are incorporated or come alongside with that syngas. That gives you a very low cost electricity, of course, but that comes at a great cost of the climate action. So greenhouse emission is very high in this case. So this has been the optimum case. This can be a very good idea to eliminate the greenhouse emissions, and the cost of electricity can be reduced as well. So UCG, IGCC with carbon dioxide removal through CCS from syngas. So this can be the savior project for the mankind. And there are beacons of hope, like this is a place in Canada. This was an underground coal mine, and this is called Legacy Underground Mine. And the underground mine, this was never adopting to clean coal technologies, technology things, but now after years of its extraction, so the management is converting legacy underground mines into large-scale, low-cost bioreactors. So I told you that there is biotechnology in coal. So they are having a trial in that coal field. So this is a very large-scale operation, of course, and so for thermal energy storage. This has been a subject of two large-scale Canadian research projects. So this project especially is a bioconversion of coal by enhanced engineering pathways into fuel products. So it explored extending the life of coal-bed methane wells by injecting nutrients to feed the microbes already present in the coal seam as a way to produce more methane. So that is how the existing facilities, which are really not worth in terms of the greenhouse effect or global warming, those can be converted into very optimistic projects for the for saving the earth. And I will go over the summary. I have pointed out, I will show you a video later anyway. So let me walk through the summaries first. So cleaning coal and sequestering to cut the emissions significantly, raises per BTU price of what would otherwise be an inexpensive fuel. So, while selling byproducts like gypsum or commercial carbon dioxide for sodas and dry ice can offset the price of clean coal technologies also. So these are the options. These are the options that the investors can think about. A charge on carbon could make emission reduction financially realistic. And since alternative forms of energy cannot yet replace a power source as cheap and plentiful as clean coal technology promises to mitigate the increasingly severe climatic effects of coal emissions. So, and the utility companies and business companies do not, however, they always accept technology purely for the sake of the environment. The technology must first make economic sense to get popularized. So those research and development techniques, those have to be first proved themselves as economically feasible to be uptaken by the utility companies and business entrepreneurs. So to comprehend that, it is possible to use the energy stored in the coal both in economic and environmentally sensitive way. That will be an expected outcome of this clean coal technology session. If you think it is possible, economically and environmentally sensitive way, coal energy can be harnessed. And needless to say that conventional mining methods of open pit or underground mining, or the way we extract the coals on the surface and burn them, are related to several formidable nuisances: these air, water pollution, public health hazards, agricultural land disruption, dislocation of habitats, subsidence, etc. So these things are the havocs which happen on the earth due to the conventional mining methods. So the savior projects, which I think is that the unconventional coal mining methods, those in the contrary, they can effectively reduce many of those hitches straight away. So these methods, except that borehole mining method, this converts the resource into energy in situ, I mean in the place. That no need to get the coal out on the surface. So physically coal is not exposed onto the surface. Thus the problems associated with coal handling and managing are readily removed. So now the problem, after all these things, the problem still exists in excess carbon dioxide, which is a byproduct of all kinds of coal energy and the waste heat. So people are constantly researching on those things, and the CCS is on the way. CCS has been greatly popularized around the world. There are lots of plants that are still in operation in development phase. So we have the beacon of hope that these things can can save the earth right away. So in a very short span of time. So those things can be taken up. So that's all. That's all from me. I have finished. The talking session. I will show you a video clip from a Canadian CCGT power plant, combined cycle gas turbine power plant. But okay, just do you want a break? One more time now. We still have half an hour. I have a 10 minutes video clip, and you guys can talk the rest of the time. So what do you prefer? That's what I can ask.
You can show us the clip.
Okay, you want to see the clip first. Okay, so this will be a follow-up clip from that Thailand video clip which I showed you in the beginning. That was a plan for Thailand, and this is what Canadian power plant already implemented. So, and they also told that, okay, just you see this first and then we'll talk.
Coal. Over millions of years, terrestrial and marine plants and animals become buried under sediment, rock, ash, and mud. A lack of oxygen and tremendous pressure combine to chemically change the carbon-rich organic matter into a mixture of compounds we call fossil fuels. Coal is the most plentiful of fossil fuels on the planet. Like petroleum and natural gas, coal releases tremendous amounts of heat when burned. If energy was the only consideration, fossil fuels would be a nearly ideal energy source. They are transportable, storable, and energy dense. Almost all aspects of human society are now tied to the use of fossil fuels in some way, including electrical generation. 22% of all electricity in Canada and almost 70% of the electricity used in the United States is generated by burning fossil fuels. Here in New Brunswick, the Belledune coal-fired thermal generating station above Bathurst, with a capacity of 490 megawatts, accounts for around 20% of the province's electricity. The plant is now a little over 20 years old and is run by a staff of 50. Coal has two serious disadvantages shared by other fossil fuels. First, it is a non-renewable resource. Although there are ample coal supplies presently, these are diminishing. Second, and most sobering, is the recognition that the burning of all fossil fuels releases toxins and greenhouse gases into the environment. Greenhouse gases contribute directly to climate change through the greenhouse effect by trapping heat inside the atmosphere. The mining of coal also has negative consequences on the environment and human health. There is no easy solution, yet. Let's look at the pros and cons of coal and see how utilities are working to maximize its benefits and minimize its harmful effects. Coal is brought to Belledune's port on the Bay of Chaleur by cargo ship from around the world. This ship unloads the coal by conveyor belt. For other ships, the Continuous Ship Unloader, or CSU, is used to unload more than 2 million kilograms of coal every hour. The coal goes on a system of conveyor belts that are over 3 kilometers in length. The conveyor belts move the coal to storage facilities until it is needed in the plant. Several different grades of coal are delivered to Belledune. These different coals are combined for their chemical properties to produce the best heat at a reasonable price. High-grade coal comes from Colombia and is stored in the huge coal house. The coal house can hold 120,000 tons of coal, or enough to run the generating station for 30 days. 10 times that amount of cheaper, lower-grade coal from the western U.S. can be stored in the coal yard. Petroleum coke, a byproduct from refining oil, comes from the Great Lakes region and is stored in the coal yard. Belledune coal first needs to be crushed into a fine dust before it can be burned. This job is done by 5 separate pulverizers. The fine coal dust now makes its way to the boiler, which is the heart of every thermal plant. The boiler is a 12-story tall furnace suspended from the roof. The Crushed coal dust is mixed with air and injected into the boiler where it burns to produce air temperatures of over 2000 degrees Celsius. That's easily hot enough to melt iron. Now to make steam. Water that is superheated has to be very pure or it will quickly corrode the pipes of this closed-loop system. Fresh water is demineralized and purified right in the Beldoon facility. Then it is piped under pressure through the intense heat of the boiler. The result is high-pressure steam at 540 degrees Celsius. The energy from coal is now energy in pressurized steam. This next part should look familiar. The high-pressure steam is forced through the turbine blades, causing them to rotate and spin the generator at 3,600 RPM. The Beldoon thermal plant has produced electricity. All thermal generating stations, like Beldoon, deal with the transfer of energy. The thermal energy from burning coal is turned into mechanical energy or work by heating water to steam and using the pressure of the steam to spin the turbine. The generator transfers the mechanical energy to electrical energy. Largely due to heat loss, this process is about 33% efficient. That means that only about 33% of the energy in the coal is converted directly into electricity. Few other fuel sources can respond so quickly and predictably as fossil fuels. Let's examine the technology used to lower waste and increase efficiency. After the steam passes through the turbine, it needs to be cooled back down to a liquid state. This happens in the condenser, where the steam pipes pass through cold ocean water. Beldoon draws over 10,000 liters of cold water every second from the Bay of Chaleur to perform this heat transfer. The greater the cooling, the more efficiently the entire system works. This warms the seawater by about 10 degrees Celsius before it is sent back out into the bay. The flue gas leaving the boiler is still very hot. Rather than waste this energy, the residual heat is used in many ways throughout the plant, from pre-warming air to reducing nitrogen oxide emissions. This is a cost saving and helps increase the station's efficiency. What about reducing emissions? When coal is burned, it reacts with elements in the air and creates flue gas. Flue gas contains oxygen, nitrogen, and a lot of moisture, but also carbon dioxide, ash, and trace minerals. This needs to be cleaned up before it is released into the air. The first step in purifying flue gas involves removing the particles of ash. There is a fine dust called fly ash and a coarse dust called bottom ash. Because bottom ash is heavy, it falls to the bottom of the boiler. It is removed by conveyor belt and trucked to the landfill. Beldoon produces 35,000 tons of bottom ash annually. That's as much weight as 100 Boeing 747s. Fly ash is removed from flue gas in a device called the electrostatic precipitator. Fly ash particles are electrically charged and stick to metal plates, just like static electricity makes your hair stand up straight. From there, it can be knocked loose and collected. Fly ash is an important component in the making of Portland cement. Over 99% of the fly ash is collected in this way and sold. It is not released into the air or sent to a landfill. And the recycled ash reduces the need for new raw materials that would have to be mined from the earth. That accounts for the ash. Now flue gas moves to the FGD, or flue gas desulfurization unit. Coal contains small amounts of sulfur. Cheap, low-grade coal has more sulfur than expensive, high-grade coal. When coal is burned in the boiler, the sulfur combines with oxygen to form sulfur oxides. Sulfur oxides are the cause of acid rain. Since 1993, the law requires that generating stations remove 90% of the sulfur oxides from flue gas. This is done with the help of limestone. Limestone is ground into a powder and mixed with water to create what is called slurry. As the flue gas rises up the FGD, slurry is sprayed down from the top. Limestone in the slurry chemically reacts with the sulfur oxides in the flue gas, producing gypsum, the major component of gyprock or drywall board used in home construction. The gypsum is collected and is sent by train to centers like Montreal to drywall plants. Belledune was the first electrical generating plant in Canada to install an FGD unit. At this point, the flue gas is mostly oxygen, nitrogen, carbon dioxide, and water vapor. Oxygen and nitrogen are harmless gases, but carbon dioxide is a greenhouse gas responsible for global warming. Between 2.5 and 3.7 megatons of carbon dioxide are released by Belledune Generating Station every year. That's about the same amount of carbon dioxide emitted in a year by 600,000 cars. At this time, there is no economically feasible way to remove the carbon dioxide from the flue gas, and it is not required by law. Carbon capture technology is still developing. The flue gas is released into the air by passing it through a 168-meter tall stack. The white plume coming out of the stack is actually just water vapor. The other gases are invisible. Coal is an important source of electrical generation for New Brunswick. It is reliable, inexpensive, and can respond to changes in demand. More coal can be burned if demand increases. Technologies have developed to increase efficiency and reduce the release of pollutants into the environment. But perhaps the biggest environmental challenge that faces the planet today is global warming and climate change. Carbon dioxide is a chief contributor to the problem. Now that you've seen how a coal-fired generating station works, how do you think New Brunswick can overcome this seeming impasse?
Hello. You here with me?
Yes, sir.
Okay, so I have done my part. I think I have shown everything I had. That was all. And yeah, just I'll sum up. Yeah, I'll sum up at the end. But before summing up, I want to hear from you guys, the ladies and gentlemen. Just come forward and share your views, share your ideas with me now. What you have come up with after this session, or did this add something to your perceived knowledge before, something like this. So whoever wants to talk about that, please come forward.
Yes, sir. I'm Emeline. Great day
Yes,
to all. From the Philippines. I'm so much thankful. I'm very thankful for this session today because honestly, I have a very limited knowledge on this coal energy. Although what I have realized after this session, after your lecture, that really this clean coal technology is very promising, and this is a very a significant, effective way for us to really protect our environment. But as what you have stressed on the video that have shown a while ago, that aside from being promoting an environment wellness, really companies have to consider its economic aspect, the business aspect of it, which That is the very thing that seems worrying me a bit, if I would say, because here in the Philippines is a developing country. Of course, we really can't afford such plants. We really can't afford such plants because, as you have lectured, it's very costly. And from the video materials, uh, countries, developed countries are the one who really can establish one for this one. So I'm just a bit, I don't know, sir, if there is uh, there is another initiative or another effective way for us in developing country to really put this into place. Although not really having a clean coal power plant here, but just I am thinking about how really the government would consider this in policies or in laws to really strengthen the mitigation for the disadvantages of using this coal as our energy source. Maybe my colleagues could also supply some intelligent inputs.
Yes, Ms. Emily. Yes, there are these concerns. This CCS technology is imperative. It has to be taken up. Without that, what the IEA, International Energy Agency Executive Director, what he mentioned, that without this, without CCS, the global warming is unstoppable. The climate change cannot be handled without this thing. So this is imperative. It has to be taken up. But what you mentioned also, and what I tried to show also, that it is still under research and development phase, and only the richer countries can afford that luxury. If I can say like this, but there are growing concerns. There are lots of international funds coming in. Those are coming for the developing countries, developing states. And the last session I had before this SDG, that there is a big matter of financing through partnership. So those may be the only option that the developing countries can also achieve some kind of carbon emission reduction policies, or some kind of trialing, just they can move forward with some kind of financing, and that is possible. And United Nations and SDG agenda, those are looking into these factors, that CCS has to be taken up, but they are due to the COVID situation, actually everything is halted or not going properly. But still people are optimistic, and CCS, I tried to show you that report. That report says that the CCS ventures are very optimistic, and not only the richest countries, some middle income Asian countries, they are also looking into looking into some projects which are coming very early. So let's wait for the interventions. Our governments are thinking, and they are talking all over the world to make these things happen. Let's be optimistic. And thank you, Ms. Amanda.
Yes, thank you so much for that, sir. It's very promising indeed. Really needed those financing support.
Yeah. Anybody else wants to join?
Sir, I think I should give some comment.
Mr. Aman, please.
Yeah,
Please.
Ms. Ama. Actually, since I learned that it was coal was the primary source of energy in the Philippines, and actually in the whole world, I was yet truly sad because I know the bad effects of this coal, because this is one of the most carbon exhausting fossil fuel. However, as you have mentioned lately, that even though this is the shall we say not so environmental friendly fossil fuel, there is no taking in the future. There is no stopping on the usage of this coal as the source for power plant in creating electrical energy. However, I appreciated that currently the most governments, of course rich government, are already doing some mitigation to at least minimize the exhaust of this carbon dioxide in the atmosphere. It is new to me that they are already making ways so that the carbon dioxide will not be emitted in the atmosphere, since they are not yet about to stop the usage of coal. That's all. That is just some realizations. Thank you very much.
Thank you, Mr. Aman. Thank you so much for this nice brief. So there are options. There are options, and people are really working, and it's moving forward. That's the beacon of hope that is moving forward fast, even in this COVID-19 situation. So everything is going on well. Let's see how far we can reach. But personally for myself, I really want to look into the unconventional coal mining methodologies also. I want to emphasize on that part. Besides CCS, CCS is imperative with every kind of fossil fuel burning plant. There has to be CCS, but as coal is the major source of energy still in the world, so I really want to look into that prospect. If the coal doesn't have to take out on the ground and doesn't have to be burnt on the ground, I want to see the viabilities or the feasibilities of that technique called underground coal gasification. That's my research area also. I'm working on that thing. I want to see how feasible is that, and if that can be conjointed with the CCS and that integrated gasification combined cycle power plant, so that can really be a game changer. I believe, and I'm still looking forward to have these answers. Pray for me, please. And let's see. Thank you, Mr. Aman. Who else?
Sir. Sir.
Who is this, please?
This is Melissa from the Philippines.
Sure, please.
Yes, sir. I wasn't able to finish the whole thing. I started only about 40 minutes of the presentation, and I only got to appreciate the type of clean coal facility you have there in Thailand.
Okay. Did you see the last video clip?
Oh, but I have some sort of background with coal. I really appreciated the part that there were mitigation strategies, like from transport of the coal, maintaining a certain speed of the barge, and then another one was the closed loop process for the coal. So from as you can see in the process for Thailand, there were so many mitigation processes during the transport, the processing, and from the release. Unlike here in the Philippines, in contrast, coming from the implementer's point of view, all I could see here that is really implemented is what we call the tail end pipe, where we only control up to the pollution part, or the pollution end pipeline of any technology, not only for coal but for any process or for any industry. We only mitigated the tail end pipe. So I really think this would be a very good baseline on how we can implement our laws here in the Philippines. So that would be all for my input on this. Thank you.
Thank you, Ms. Melissa. Yeah, that is a very growing concern that there are thousands of coal-fired power stations around the world, and many of them really do not care the coal handling, coal transportation nuisances. These actually degrade the environment so badly, so badly. So the coal transportation those should be well covered, closed loop, what is that called? Closed loop transfers should be implemented, and there are those sprinklers or coal washing for the primary cleaning thing. So these things should be mandatory and should be adjusted into the policy of so that the mitigation of the coal burning nuisances can be just addressed a little bit in the primary phases. So that can really help these coal nuisances. That's what I can say actually. Thank you, Ms. Melissa. Anybody else?
Hello, sir. This is Christine from Guyana again.
Please.
Hi. So just following up from my initial comment in the beginning.
Yeah, I would like to hear that also.
Yes. So I definitely learned a lot about the clean coal technology that is available, right? But to be honest, I'm still not convinced because I read statistics that said that the coal industry in 2020 has dropped to the level that it was in the 1960s. And then throughout the presentation, I was listening and it says that there is a lot of coal, but that's for the 21st century. So now I'm thinking about the future, and I'm thinking about in the beginning, we start talking about mitigation measures and adaptation measures. And I don't think this is offering us a permanent or a sustainable solution for the future. And in this part of the world where I live, we don't have coal plants. In Guyana, now we're exploring oil and gas. But what I can say, I don't have a personal connection to it. I know a lot of persons in other places, they're employed by the sector. And you talked about that in the presentation. There's a lot of economics, indirect and direct, that's associated with it. And I know in the US, what they're looking at is energy just transition. So understanding that a lot of coal plants are going to be shut down, but offering sustainable job opportunities to people and businesses that depend on the coal industry. So that's all I have to offer. Thank you so much for presenting. And I definitely have a new perspective on what's happening in the quote unquote clean coal area. I definitely have a deeper understanding of it, even though I may not endorse it fully.
Thank you, Ms. Christine. And thank you for being honest, actually. Yeah, these are the perspectives everybody bears these kinds of perspectives. So these are the things happening. I just can tell you that I am trying to dig deep into the coal technologies. I am working in that field. I am from Bangladesh and I work in the energy ministry in the coal sector. And I really want to give my country hope for the near future, because our country needs lots of energy supply in the near future, and our we have natural gas is depleting, and many of the developing countries and many countries around the world have the same situation, that they have only left coal. So if you have also seen in the statistics that still in 2019 it was 36.4% 36% coal actually. The major share was coal. So and I tried to say that the coal is not going anywhere very soon. So we have to learn to live with this thing. And the only thing we can cope up is that we can try to diminish the adverse effects of this thing. So we are looking for those options. CCS is certainly giving us a brighter opportunity. And what I told you that my research area, and I'm looking into the unconventional coal mining methodologies. I don't want to bring the coal out onto the surface, which primarily poses the great problems for the environment. Then when you start burning, then the second generation of emissions and these disturbance of coal, fly ash, bottom ash, these things just mess up the whole environment. So I want to get rid of all these things first. Then I just want to deal with the carbon dioxide. Whenever coal is buried underground, those are not excavated onto the surface, we don't have to worry about those coal handling, washing, fly ash, bottom ash, these things. We just have to think about how to handle the carbon dioxide, the excess carbon dioxide. So that there this option comes, that CCS. So we are waiting for this CCS to become viable, that operational feasibility is possible for every scenario. So for these things we are waiting, and that thing what I am researching, that underground coal gasification, that can be combined with all these things, and that can be really a beneficiary project. I'm really looking into that thing. I want to be optimistic about coal, still the largest fossil fuel in the world and readily accessible. Still we have to go with that. That's all I can say. Thank you, Ms. Christine, again. Anybody else? We have just finished the time anyway. If you allow me, I will close down the session.
Go right ahead, sir.
Thank you so much, sir.
Thank you so much. Thank you so much. And this is my last session with you guys.
Thank you, sir.
Okay. Mr. Rama, and thank you so much. Thank you so much also. Thank you everybody for joining this training program. And thanks from me. I'm so happy to be acquainted with you guys. Hope to see you sometimes around the world, anywhere in the world. So just take best care of yourself. And I bid you goodbye from this point. Take best care of yourself. Stay safe and sound.
Thank you, sir.